Hello, everybody, and welcome on this wonderful Sunday evening, at least it's evening for me, to Advent of Code 2022 in Kotlin. It is day 11, so yeah, I'm excited. A little update. As you remember, last night's stream was slightly moved forwards because we had a Christmas party at JetBrains. That was a lot of fun. It was good food and entertainment, and I got to see my colleagues face to face again, which is really nice. But it also meant that I got approximately 4.5, maybe 5 hours of sleep tonight. So it really feels like the first few days of Advent of Code all over again. Kind of slightly sleep deprived. That's kind of... maybe that's how it's supposed to be. Maybe that's just how it goes. Well, you know the drill by now, I think. If you are in the stream, make sure you say hello in the chat. And also let us know how the problem, or solving the problem, went for you today. How you found it, whether you enjoyed it, if it was difficult enough. Let's hear some opinions there. Deep access, ready to learn. And that's what we like to hear. I think we have a couple of very cool topics that we're going to talk about. I did have a little bit of a peek into kind of what we're going to be discussing in advance, and I think it's going to be a very good time. Today, I'm unfortunately covered by a very boring tea. This is just chamomile. But, you know, you gotta shake it up a little. You can't always have the really good stuff, right? You gotta switch it up sometimes. Let's see here. Not even joking. Says, the problem was fun. Took me a bit to find a solution, though. Finished after about 40 minutes after releasing. Frozen says, felt like I was button smashing towards getting part 2 to work. Don't feel proud about it. Fair enough. That's okay. Tiago says, hello from Brazil, bit behind the challenges, but I love watching the streams. That's wonderful to hear. Yeah, Alexander, second part went crazy. I think we're gonna see that, and really gonna see how things can escalate and how you can stop the escalation. It's gonna be fun. Jerry asks, did you guys use regex classes for parsing the input? It's an excellent question. Stay tuned for just a little longer. We're gonna have at least a couple of answers for this, and we'll see. And Not Even Joking says, I really liked yesterday though. Nice, very good. That's just excellent. Also, good thing again, this our wonderful reading hat, which is necessary for the dramatic reading, has also successfully survived the Christmas party. I did wear it as a fashion accessory, so as to not just be dressed up in like a shirt and tie, but get a little bit of festivities going. Alex says, use a lot of string properties on this one instead of regex. Nice. Vitek says, if there's a lot of numbers on one line, then it's convenient to use a regex. Yeah, certainly, that's one way of doing it. And I think we're gonna see a couple ways of how you can do it, probably with even avoiding regex. I remember I didn't actually use a regex today, but there was a lot of input parsing happening. Leaned heavily on string splitting to quickly parse input. Yep, Frozen, that sounds about right. Okay. Well, I think we've given people plenty of time to join. So for everyone who has arrived in the meantime, I want to say welcome again. Say thank you so much that you choose to spend your Sunday with us, and we'll make sure that it's the best decision you could have made. Because I'm very excited about our guest today. Our guest is someone that you might already have seen a couple of times in our chat, and even at least his creations have been on stream. It's Olaf Gottschalk, who's been a software developer at BMW now for over 20 years. Hi, Olaf. How are you?
Hi, correct. Hi, Seb. Hi, people. Yeah, that's correct. For over 20 years already, I'm a software developer at BMW. Yeah, correct.
Wow, that's a long time. But
Yeah.
I assume that if I'm doing the math correctly, Kotlin isn't actually 20 years old. So how did all of that begin for you?
Yeah, that's exactly true. So basically, when I started developing, it was more like the usual stuff. I did lots of Perl in the beginning, and Pascal was my first language. And then at BMW, many years passed without any big changes in this stack. But then Kotlin came to the world, and I got introduced to it because of Android development moving to Kotlin. That was basically the inception for me, how it happened. So I got a pet project. The only thing I do with Android is a little timetable for our buses here in Munich that go between the buildings that we have, different locations. So I thought it would be really useful for our colleagues to have a timetable in their hand, and so I created that app, which used to be a Java app. And of course, when Kotlin came, I quickly looked into it, and I fell in love almost immediately, I would say. Yeah.
Nice. And I guess since then, you've been going all in on Kotlin wherever possible.
Yes, wherever possible. So another thing that I really love to do is, and that's something for over 6 years now, is I'm hosting coding dojos at BMW to get other colleagues like more into programming and better programming. So I really enjoy and get into the world of clean code by Uncle Bob. And so when Kotlin hit that, I was like, wow, this is finally an expressive language where you can really reveal intent. That's one of the main strengths, I would say. And I immediately loved the null type feature of Kotlin. That was basically the intro for me to it. So when you have done some Java projects and when you want to do clean code, you immediately notice that something is wrong in that Java world with always having to fear the dreaded nulls. So that was basically like the thing that got me hooked into Kotlin. Yeah. But there are many other things that came to it. Like Kotlin is the language that got me into functional thinking and functional programming. I mean, that's not the first choice you would think somebody had. But once you love this expressiveness, you feel that there is more into it. Yeah.
Yeah. I have to say, it does sound like music to my ears when you say that Kotlin is excellent at expressing intent, because this is something that I've been kind of on about for a while now, and I've been even more vocal about it in the last couple of months. Where if people kind of ask me about some kind of code quality question, I'm usually like, well, probably choose the one that expresses your intent better, unless you really need the extra slight boost in performance or something. You can oftentimes get away with so many like built-in functions as well from the standard library. So yeah, that's my you've definitely hit a sweet spot there.
Yeah. And once you are into that, you basically, Advent of Code is a great driver to see what's in it in the standard library, and also, and we've seen that on your stream in the past days, also what's missing. I enjoyed the talks to your colleagues about what could be added to the standard library, like the take function that should bring this last element into it. I actually programmed my own take until, so as opposed to take while, just to solve that problem. But I know that take until is also not a proper name, and I can really feel the pain of finding the right name for that.
Yeah, that's kind of the problem that we have, is that our until ranges are like open end, right?
Yes. Yes.
That's a bit of an issue there as well.
It's really troublesome.
I want to quickly circle back to the like coding dojos.
Yeah.
Would you kind of say that like Advent of Code problem statements also help illustrate like similar things that you do in those dojos, or would you say these are rather separate?
Sometimes I mix them up. So Advent of Code is also a great source for having coding dojo katas. And actually, like for like 5 years now, I'm doing the special event of Advent of Coding Dojos at BMW. So I invite my colleagues to hop onto our internal leaderboard and to join our WhatsApp group and our BMW internal chats. And we have a daily every day at 3 o'clock in the afternoon. And I must say, with every year passing, this group gets larger and larger. We haven't yet hit the limits of like 6 leaderboards that you have, but I got 1 leaderboard and it filled up this year completely. And I had to clean up at the lower end of that leaderboard. You know, probably Eric should go into that one because 200 is really a strange limit. And also, I don't want to kick out people that participated 3 years ago because a leaderboard persists over all of the years, and I really enjoy that. So I can go back in time and look at the leaderboards from 2019, for example, see how we did there. And today we have like almost 70, I think it's 70 people who are up to the current day this year in BMW, and that's quite a lot, I think. I mean, it spreads like Eric explains in his great video. He wasn't sure how many people could be interested, and then it exploded. And I hope the same thing happens internally. Yeah.
That's really exciting. So just for me, for context, so I can kind of visualize this in my head a little bit, which is also a topic we need to talk about. During your daily, is this kind of a similar thing to what we're doing on stream here, where you're like discussing the solutions together? Or?
Exactly. So I got a little bit of practice in the past days internally with my colleagues, and it's always fun. I mean, even at 6:15 or 6:30, depending on the problem in our chat, you hear the first noises. So I have to mute my phone not to get distracted and see I'm the last to join or not the first. So this year I got really great competition, people who are way faster than I am. But I'm happy because I got my colleagues into this, and I hope this strengthens the community quite a lot. I think every company with IT people should look into that. It's like a no-brainer to do that. Yeah, that the time spent is so much worth it.
Nice. That's really, really good to hear. So we obviously at some point need to talk about all the cool visualizations that you've built, but I feel like maybe this would be better served as kind of a treat after we go through today's problem, so that people have something to look forward to. Would you agree with that?
Absolutely.
Okay, wonderful. Then I think with that, because we do have a bunch of stuff to get through, I'm gonna put on my reading hat and we're gonna dive straight into the dramatic reading, so that we can see what's happening today and what we'll have to do to save Christmas. So, let me just open this up here. And of course, this is also a brief reminder for everyone who has not yet joined our leaderboards to go to the Advent of Code in Kotlin 2022 blog post and make sure you join one of the leaderboards that I mentioned in that blog post. If you are on YouTube, you can find that one in the description. If you are on Twitch, you can find that one on YouTube. Which, yeah, you'll find it somehow, I'm pretty sure. As a reminder, we will have a few prizes for people who rank really highly, but we also want to give people who are just working at their own pace and leisurely a chance to win some exclusive Kotlin swag. So make sure that you make your repositories open, you tag them with the Advent of Code 2022 in Kotlin topic, and you have some kind of way of contacting you in your profile as well, so that we have a way of actually giving you things. And reminder, this is exclusive stuff. After this campaign is over, you won't get a chance to get this stuff again. So make sure you get in on it while it's hot. Okay. Jonathan, hey, nice of you to join us. No worries, you didn't miss anything yet. We are just about to start with the discussion of day 11, Monkey in the Middle. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. To get your stuff back, you need to be able to predict where the monkeys will throw your items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. You take some notes, your puzzle input, on the items each monkey currently has, how worried you are about those items, and how the monkey makes decisions based on your worry level. For example, Monkey 0, starting items 79, 98, operation, new equals old times 19, test divisible by 23, if true, throw to monkey 2, if false, throw to monkey 3. Monkey 1 also has a bunch of starting items 54, 65, 75, 74. Operation is new equals old plus 6. The test is divisible by 19. On true, throws to 2. On false, throws to 0. Monkey 2, same story. This time the operation looks a little bit different. It's not a plus anymore like we had up here. It's new equals old times old. It does divisibility by 13 and it throws to monkeys 1 and 3. Monkey 3 starts with 1 item 74, adds 3 during its operation, tests if things are divisible by 17, and based on that, throws to monkey 0 or monkey 1. Each monkey has several attributes. Starting items list your worry level for each item the monkey is currently holding in the order they will be inspected. Operation shows how your worry level changes as that monkey inspects an item. An operation like new equals old times 5 means that your worry level after the monkey inspected the item is 5 times whatever your worry level was before inspection. Test shows how the monkey uses your worry level to decide where to throw an item next. If true, shows what happens with an item if the test was true. If false, shows what happens with an item if the test was false. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the nearest integer. The monkeys take turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding one at a time and in the order listed. Monkey 0 goes first, then monkey 1, and so on until each monkey has had one turn. The process of each monkey taking a single turn is called a round. When a monkey throws an item to another monkey, the item goes on the end of the recipient's monkey's list. A monkey that starts a round with no items could end up inspecting and throwing many items by the time its turn comes around. If a monkey is holding no items at the start of its turn ends. In the above example, the first round proceeds as follows. Monkey 0. Monkey inspects an item with a worry level of 79. Worry level is multiplied by 19 to 1501. The monkey gets bored with the item. Worry level is divided by 3 to 500. Current worry level is not divisible by 23, so the item with worry level 500 is thrown to monkey 3. Monkey inspects an item with worry level of 98. The worry level is multiplied by 19 to 1862. Monkey gets bored with the item. Worry level is divided by 3 to 620. Worry level is not divisible by 23, so the item with the worry level 620 is thrown to monkey 3. And that continues on for all of the monkeys, which are a couple of them. I'll spare you me reading all this out, but I think it would be maybe a nice good night story if you really want to fall asleep. In conclusion, after round 1, the monkeys are holding items with these worry levels. Monkey 0, 20, 23, 27, 26. Monkey 1, 20, 80, 25, 167, 207, 401, and 1046. Try to cram as many different ways of pronouncing the same numbers in there for some reason. Monkey 2 and Monkey 3 aren't holding any items at the end of the round. They both inspected items during the round and threw them all before the round ended. This process continues for a few more rounds, and we see more operations happening and items being thrown around between the different monkeys. Chasing all of the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys if you want any hope of getting your stuff back. Count the total number of times each monkey inspects items over 20 rounds. Monkey 0 inspected items 101 times, Monkey 1 inspected items 95 times, Monkey 2 7 times, Monkey 3 105 times. In this example, the 2 most active monkeys inspected items 101 and 105 times. The level of monkey business in this situation can be found by multiplying these together, which is 10,605. Figure out which monkeys to chase by counting how many items they inspect over 20 rounds. What is the level of monkey business after 20 rounds of stuff-slinging simian shenanigans? Whew. All right, Olaf, where did your mind go when you read this one?
Yeah. First of all, I thought, like, why on earth do I have to have this puzzle on the day I want to be on your show? Yeah. I've been doing Advent of Code for a long time, so I'm pretty used to reading that much text or skipping that much text. So most of the things in this description I have to skip, so it takes me quite a time to scroll up and down and don't miss one minor really, really important thing. Yeah, so I know this description is like including every detail, but I do also know that it's not relevant for me when you understood the problem. So
yep.
Yeah, the scrolling is really awkward. Yeah.
It is.
But nevertheless, that's one of the challenges you face every morning, like, and it won't get better.
Yeah. So I think at least for this one, so first of all, I was immediately reminded of just like Gibraltar and like the monkeys there who are like notorious for stealing stuff out of tourist backpacks. But yeah, just because you mentioned you still gotta read closely enough to figure everything out. I think at least for me that was the case with this being divided by 3 and rounded down, because that's kind of like, it doesn't really appear all that often in the whole text.
Yeah.
It appears in the samples once or twice, but the fact that these have to be divided only shows up pretty subtly.
It's like yesterday's X starts at 1, for example. That was such a classic. So nobody expects X to start at 1. And here it's the division by 3. If you don't spot that, got a problem.
Yeah.
Yeah.
Okay. So, shall we have a look and see how you try to solve part 1 of day 11?
Definitely.
Pop this one open here.
So
you have your cursor.
yes.
So you can just guide us.
So the problem, as you've already noticed in the chat and the comments, is also that you have to parse input data. I mean, there are some Advent of Code puzzles where it's quicker to type in the 5 numbers that are relevant. But in this case, I didn't want to do that, so I knew immediately we had to somehow parse this. And in the past days, I mean, people have already seen how this is done. Like it's a grouped input, and you can see here in my setup. So basically, a few words about that. I got a base class day here, which has some of my tools, my standard AOC library. You would say that.
Okay.
So
should we have a peek inside?
It's yeah, you can peek in there, just jump in there. It's a lot of stuff. Like
okay,
yes.
You came prepared.
Yes. So you see, I got different input types that are already made, like grids, ints, longs, strings, and I also got this grouped input one. So input as groups, what I'm using today, immediately delivers the groups with a standard delimiter of 1 empty line. Yeah. So the group delimiter here is string is empty, and so you are started very quick. Yeah.
So this would be the thing that we were missing on day 1. This is what really gives you the speed boost there.
Yeah,
okay.
But on day 1 it's completely irrelevant. So I'm not the fastest, and I always struggle with myself. Like, I have a hard time doing it not clean. So that's always my first thought. Like, okay, I gotta parse this. How do I do this quickly and not that unclean? So. Jumping back to the day, you would see that the parsing stuff. So what I like to do is, because at some point my head explodes when I have too many things that I have to juggle. Like we've seen Roman's approach with the short names, and I know I've tried code forces, I'm not that type of a person. It's too abstract for me most of the time. So that's why I like the stories in AOC. Even though in the morning I rarely read the storyline, yeah, but still take that away and I'm bored a little bit, and it's only mathematics only. Yeah, of course that's fun. So I like to stay close to the story from the very beginning. So what I like to do is parse the input into classes that hold like everything that's relevant. And of course, speaking of the domain here, we need monkeys. So my first task was get the input into monkeys, because that's what we need here. The monkeys play with each other. And you can see, now skipping a few parts here, but I get my groups right about the input as groups. And all I provide here is what do I want to map every single group to, and every single group has to be mapped to a monkey. So I want to have the monkeys. Oops, let's go back. So how do I do this quickly? I take the group and I use destructuring, dropping the first line which holds the monkey number, and then you can see immediately the monkey has a few fields, and we can jump over to the monkey quickly. The monkey has the worry levels, and here also this is something I dislike a lot. It's like when I try to build my domain classes, like the monkey has items, and in this story again, the items are never referenced. We don't know what the items are, we just know the worry level that I have about the items. So this here makes me not very happy. Like, the monkey doesn't have my worry levels, but I needed to model that. And time was ticking, so I did it like this. So we got the worry levels, we got the operation, and here you can already see how most of my thoughts go. Like, if I have an operation, I immediately type in the signature of a lambda function. So the operation takes an int value and delivers a new int value. Because, to be honest, when I read the storyline, I didn't even look that there is only add and multiply. So I was prepared for any kind of operation, and I did this like immediately. Any operation could serve here. Yeah. The test is the value to test. In the beginning, this is not the very first code I wrote. In the beginning, the test was also a lambda, it's a predicate. It's a predicate taking an integer, delivering a boolean. That's what it is. But this has already been changed here in this code base. So if true, that's another thing. If true, throw it to monkey blah blah blah. So I'm not very proud of that, but I want to show you how this all comes to life. So if true is the monkey that receives it if the predicate holds true. If false is the other monkey. And yeah, going back to the parsing, a few little tricks I use here is, so looking at the lines coming from each group of descriptions, dropping the first one. This one was necessary. You had this on the stream. The list class doesn't provide you with more than 5 component operator functions. So you immediately get into trouble, and I got this, like a squiggly line doesn't have component 5 or 6, I'm not sure, it's counting up 1, yeah, so it must be 5.
Yeah.
6 was missing. But I was lucky, I could just drop the first line because the monkey number was irrelevant, and then it worked out fine again. Otherwise I would have been screwed at that point already, yeah, being quick. And then looking at the, so I've tried to be brief, items, the operation, the test, true and false. And you see there is another helper function, extract all integers. That's also in my library. So given a string, pull out everything that could be an integer out of the string. That's immediately doing the business for me. It works internally. Yeah, you see how it works. It goes into a sequence. And over the years, this got refined more and more, like include negative numbers. If you look at the pattern, the number regex pattern up on screen, you see I'm looking for anything that could be an integer number. But sometimes, like in this year already, if the puzzle has a dash not as a minus, then you fall into a trap here. So you need to explicitly say don't include negative numbers to only get the positive ones. But in this case, it was all easy, so we could just extract all integers and we are happy. That's what I do in part 1.
Yeah, this is a nice, by the way, answer, I guess, also to did you use regex to parse the input today? I guess the answer is yes, but
no.
you already had that one ready.
Yes, yes. It's like your standard library. It's tested over the years, and I trust that one. But as I'm the only user, of course, there could be bugs inside. Like it's a little bit more dangerous than doing it yourself, but it's also better than starting from scratch.
Yeah. Luca actually asks, you just need to add like a string component end method. So the question is that something that's planned for your own little standard library extension, just like components 6 through 12?
Yeah, maybe that's possible. But this is actually the very first time in AOC that I had this problem. So I've never really encountered the problem of not having these things. Most of the times the things are numbers, and then I use this function to get all the numbers out there quickly. Yeah, so a few more words about the create operation stuff maybe. So the operation as a string given, I briefly looked at that. So I said everything after new equals is the equation. And then I was like, okay, there is old in there, and sometimes old appears to the right side twice, like old times old. That's one of the things I saw. So a square monkey, so to speak. And that square monkey, so I needed to be a little bit clever. I'm pretty sure this is not the most clever way, so I'm destructuring again, splitting by blanks, throwing away the first one. In my very first iteration, even the first one was taken, but it's always old. So there is no operation that doesn't rely on old as the first operand.
So for context here, this can parse instructions that look like this or like this, for example, right?
Yes.
Okay,
that's true. And because in the real puzzle the first thing is always old, I opted to put a dash, an underscore there, and the underscore basically removes it and doesn't care about it. So and then you see there is another thing. How do you deal with the case that there is an old to the right side, like old times old? And the trick I came up with this morning is basically, it's a little bit for people who are not into these lambda things and functional thinking. You have to really be sure what you're doing. Like in this case, the OP2 comes from outside, so it's like a closure. It goes into the lambda, and at runtime of that lambda, it's always parsed to int or null. And if it's null, that means it's not a number, so it has to be old in this case. So if it's old, then instead of the null, I just pick the old value from the lambda input. So basically, this is the trick of doing the operations quickly. Well, quickly in terms of, for me, it was fast to type. It's not by any means efficient. It's like horribly inefficient, but it works.
Yeah. I like this. I like this pattern. I have the same pattern in my solution as well.
Yeah. Okay, so
nice.
Quick jump to the monkey, because now we get into something that I detest a lot. So when I got more and more into my clean code habit, one of the things quickly, and I'd say right after the nullability things of Kotlin, was that I immediately got into immutable classes. I really love them. So I would say 90% of all of the horrible bugs that really I spent hours with debugging, they were all related to state. They were all related to stateful objects. So what I try always, so I know that makes me slow in terms of solving the puzzle in AOC, but it makes me faster in real life projects because it prevents errors. So what I try to do is stay immutable. And here you can also see some first problems I had this morning. So the worry levels of the monkeys, they need to change. Yeah. And my usual way my brain ticks is I work on immutable data classes. So I always provide operations that transform one stateless object into another one, just values, basically. That's what immutable things are. But in this case, I opted out for that, and we will quickly see why. So I had to make the monkey a class with state to make my play of the game work. And here you see one of the things that I didn't know actually. So my monkey was a data class at first, but if you go to the inspections, maybe we jump to the only function that this monkey can do. The monkey can perform inspections. So how does that work? We know that the monkey has to look at every item, or basically at the worry level of that item. And here's one way to write that. So I got the item worry levels as a mutable list. So I introduced immutability in here because I know that the worry levels or the items the monkey holds will change. So what I do is I iterate over the item worry levels. So as long as they are not empty, I will basically pick the first item out of that and call it level. I will immediately say I got one inspection done. That's the inspection counter as a variable here. So when I introduce people to Kotlin, I see a lot of people using vars all over the place where it's absolutely not necessary. I mean, I have no idea why people can live with a cluttered yellowish editor. I'm always like, no warnings, please, no warnings. So if something can be a val, it has to be a val. And what I try to teach people is there is a reason why there is an underline under inspections. And for me, now you can correct me, now I got the right person here. In my world, the nice people at JetBrains delivering Kotlin, they want to throw something in my eye that distracts me. So to tell me, do that sparsely, don't do it that often, because if your full screen is full of underscores, it looks horrible. Yeah.
So it's an intentional nudge that makes you very acutely aware that you are using something that is mutable. And it's obviously a deliberate choice that the immutable stuff is the one without decoration, and the mutable one is the one that's got something extra that feels a little bit different.
Yes. Yeah. So I avoid these wherever possible. But here I wanted to solve the puzzle in the morning, so I put it in there. So the monkey can now count up the inspections. And here you see how I call the operation that the monkey has as its function to work on the worry levels. And here's the test. And yeah, I worked a little bit with this. I like these infix functions. The infix function basically is just a little helper down here where you see that an int is divisible by a divisor if this remainder of the divisor equals 0. So I like to hide that to make the story speak a little bit. That's just a little thing here at this point already.
Nice.
Yeah.
So it is a little nicer, and it signals intent a little bit better than having just the mod operation in there directly, or the remainder operation directly in there.
Because I'm not interested in the remainder at all. All I'm interested in is it divisible by. So that's why this intent comes better this way. So, and if we got this predicate, so what we have to do here, and this really makes me worry a lot. When I write code like this, I'm horribly afraid of doing something wrong. So what I do here is something I would never do in real projects, never. So, but many people do that. What you have to do now is, how do you get the item to the other monkey? So we have the if true monkey that should receive the new worry level. And how do I do this? Basically, I'm going to access my monkeys. And if you are looking closely here and follow the monkeys, this is my monkey setup that I parsed from the input. So I knew at this point in time, monkey in my world is a mutable class, and when I do the operations, when I perform the inspections, I will alter the monkeys. The monkey state will constantly be altered, and this is something I would never do if I wasn't forced to by the time pressure in the morning. Yeah, but I wanted to show you the very first thing I did here. So going back to what this means, and this is something I learned this morning actually. So because the monkeys, the monkey perform inspections function needs to access the monkeys, it has to be an inner class. So I don't want to go too deep into teaching Kotlin here, but this is another nice thing of Kotlin, that classes in classes are basically not inner classes like in Java. You have to specify it's an inner class, otherwise you just have a namespace for it. But I didn't know that data classes cannot be inner classes. It makes sense, it makes a lot of sense, because that's a state outside of that class instance. But I had to quickly go away from my data class. Yeah, so I had to put inner class there, otherwise you cannot access the monkeys from inside themselves. But when I do this, I already know danger, danger, danger. Yeah, so I'm adding the new item to the worry levels of whoever receives this worry level. Also, I might point out that if this puzzle had one monkey that threw items at itself, this would be immediate trouble. because I'm iterating. I mean, I did this using remove first, so this would still work. But if I had chosen a for each or for loop, this would have been, it would crash. It would crash if you try to alter the thing you're iterating over. Yeah. So basically, that's what the monkey does when it performs inspections, and it basically loses by removing his item worry levels and gives them to other monkeys.
Yeah.
So in the part 1, what did it say? We have to go back to the story. And one of the things I like most is when I'm done with the inner story and the inner behavior of my types, mostly the solutions to AOC are very short. That's the benefit you gain from doing clever or clean code, clean work outside the modeling there. Yeah? So basically what I have to say now is, we repeat for 20 times. For every monkey, let them perform the inspections. That's all you have to do. And in the end, the answer to our puzzle is, take the monkey's inspection count, so mapping each monkey to its inspection number, sort them descending, take 2, and here's another nifty thing that might help people. So how do you do the product of n elements? Yeah, of course, it's a reduce function. Those of you who are into this are knowing this. But what I did here is something more, I want to be safe. And if you take the product of an arbitrary number of ints, it very quickly explodes. So my library makes this immediately a long. So I'm going out of the int range and making it a long. But if you look at the fold operation, I'm using my own long save times function here. And this save times function is a little bit more complicated. It basically does the operation and then checks whether I had an overflow or not. And if I had one thing to choose that I would like at these points in time, like a little switch turning safety on for every operation that follows. That's what Kotlin doesn't bring. So I wrote it myself. Yeah.
Okay.
Yeah.
That's honestly a good request to have.
Yeah. Yeah, one of my colleagues told me this morning that he struggled exactly with that. So he had this overflow of his int range, and even the long range he said didn't work. But I could easily do that in my library to go to big integer if that doesn't help. Yeah. So for AOC purposes, this is completely so. I couldn't use that function in an inner loop where it does it millions of times. But I can do it at the very end. And most of the time, AOC puzzles have this now build the product of these numbers. So if I'm in the morning just typing .product, I'm very safe. It doesn't do anything that I wouldn't expect.
Yeah. Which is a good move. Not Even Joking says that last return line is identical to my code byte by byte, which is nice because that, again, I think this just indicates that if you choose the correct abstractions, you can kind of end up with code that pretty much just reflects the problem statement almost word by word.
Yes. Absolutely. Yeah, that's exactly what I like. And only when I do this in this way, I'm sure I really got the problem right in my head. Yeah? The code helps me to understand the problem if I'm at that level. Yeah, and that was it for part 1. But I got some other file for you because I already said a few times that some things that we've seen here, the mutable stuff, that really didn't work out well for me. So I want to show you how you can move that into a immutable world, and that's like more functional. So if you would move to day 11, part 1, functional,
yes, I'm with you.
You could see how I can do that.
Zoom in a little bit again. All right.
Yep. So I will briefly try to explain that, and I got lots of comments there. So if you look at my repo on GitHub, then you will see what I did here and can reread it. So basically, you see the data class monkey now is a data class. It's a proper data class. It only carries things that the monkey that's monkey business. Yeah, like the monkey has this ID. So I put it in there for another reason. You will see that the operation. This is something I'm still not happy with because the operation is still an operation I do in my brain, my worry level. But technically, because it's dependent on the monkey I'm looking at, I still left it in there. That's a thing where the real world doesn't really match the model. The test divisor, if true, if false, that's what you've seen. So here we have a monkey play result that we come to see later. It could also be a pair int, but I wanted to show that you could put more intent in there if you use that.
Give some
so
names.
what is the benefit if you do that? And now look at the start of day 1 here. You see what I do now is I'm parsing exactly the same. I'm parsing the groups to the monkeys. But you might have noticed the start items are not within my monkey anymore. The worry levels are none of the business of the monkey. But I then parse the start items as a separate parsing. Again, this is not about efficiency. It's about clear statements and saying, okay, now got the start items in a separate list. And all of those things are immutable. Because if you think about it, in my part 1, if I had stayed with the mutable class monkey, immediately when I do part 2 in my setup, I have the problem that the monkeys are all altered. Because they are mutable, after running part 1, they have different internal states. And in the beginning of AOC, I tripped over that several times. So, of course, if you want to be fast in the morning, you can, as Roman did, just delete everything from part 1, basically start with from scratch or have a copy of part 1. But in my case, I have these part 1, part 2 functions. So in my day class, there's always a part 1, part 2 function. And if I alter the state of the world in part 1, I'm into trouble in part 2. And from my experience, this is what happens to many developers in real life also. They forget that they change the world. When they have mutable objects, they instantly forget what they've done. And a week later, a month later, a year later, somebody uses that class in a different context and it's not as they expect. So don't do that. Yeah, and now you can see what's going on here. The monkey has a function, play with item of worry level. And the worry level is given in there, and here's the monkey play result. So what I do here is every monkey can play with an item of a certain worry level, and it results in a new worry level, seen here in the outcome of the monkey play result, and it has a throw to index of the monkey that should receive the object. And then the operation, this is familiar again. Okay, I didn't use my infix function here, but that's just due to my, I forgot that when I refactored the code. Here, this is divisible by again.
Sure.
So, but the cool thing is, if you do that, I mean, the code doesn't get shorter by that, but I don't have any state anymore. So let the monkeys play. This is my new function that you can throw a number of rounds in, and you will get the inspection count. Because the monkey is immutable, you have to now carry the number of inspections outside the monkey. And you also have to carry around the state, meaning what item is in which monkey's possession right now. These are two things that I create here inside the let the monkeys play function. So that's internal stuff. And internally, you can do with mutable structures like int array or immutable list. For me, personally, this is okay because it's definitely inside a function. It can never get into your way, even if you do asynchronous code. This is always safe internally. And if you are like me, I'm always jumping into the standard library, and all of the things that you do on immutable things are internally done, of course, with a loop and with mutability. But the key point is mutability is necessary, but it has to be hidden away. So I don't want to reveal my intent by having mutable things and somebody guessing what he's doing. I just want to say what my intent is, and then internally, mutability is absolutely required. Yeah.
Okay.
Yeah.
So it's all about encapsulation.
It's encapsulation. So how does it do inside the rounds now? It's a repeat now because it doesn't have to do anything else but do it n times. And here's another trick. I love that very, very much. So you see, I got inspections as an array and the current state, which is a list of mutable lists. So the list here carries one mutable list per monkey. That's the items that the monkey holds. And because I want to work on the monkey and its items that the monkey currently holds, I'm using the zip function to put them together with the same index. So inside of this block, you will always have one monkey with the items the monkey holds at that point in time. Very easy stuff. So what I like is when my brain can ease off and you can go into that lambda and you know inside this lambda, this is exactly what you want. You don't have any references to other things. So here you now say for every item the monkey holds, we want to call the play with item of worry level function and get the new level and the new monkey that it should be given to. out of the function that we've just seen. And here's my inner mutability. So I'm now adding that new level to the monkey that should receive it. And instantly after that, I increase my inspection counter to the number of items I had in stock. So I could have put a ++ inside the loop, inside the for each loop, but this is a little bit more like I'm doing it at one step. If the monkey has 10 items, it's increased by 10 here. And then one thing you have to do is clear the list that the monkey that you just processed holds. That's basically it. And if you have done that, you can now go to the part 1 stuff down here.
Sorry, can you place your cursor there and I'll follow you? Okay, here we are.
Yes, I got it here. So you see all the code that's left is total inspections equals let the monkeys play for 20 rounds. And then you do the same thing as we did without the functional approach. There is one gem hidden that I wanted to try out because I just said the inner mutability is not a problem. If you do that properly, you can do that. I wanted to try out how it looks if I really did not do any mutation at all. And just to have a peek on that, it's the other function above. I place my cursor there. Let the monkeys play more functional.
All right.
This is how my brain ticks when I'm doing functional, but I don't want to go deeper into that. But the problem here is once you are dealing with immutable lists, there is a problem if you want to change the state and you have to change one item of an immutable list. Basically, what the data classes have as a copy is lacking for lists. So what I need is take a list, copy it, but change one item. And here you can see that I wrote this function basically down here just to hide that away. So if you follow my cursor, you should see that.
Do that. Yeah.
This is my functional way to say for any item list or for any list of any type, here is a list of changes that you should apply to it. It's very rudimentary by any means, but I can say take the list, copy it, but change this item by a pair of the index and the new value that should be placed there. And that's the only way you can really do with immutable lists if you want to alter some elements inside.
Okay. I have a question for you. Do you know of the Kotlin X collection's immutable library?
I'm more into Arrow, and this is like what Arrow Lens does for me. But when I don't do it, but this one here, no, I didn't know that one. No.
Very good.
That's
yeah,
cool.
it's as you can see, it has under 1,000 stars so far, even though it's an official library that we offer from Kotlin. It is still in alpha, but it is official, which provides immutable collection interfaces and
cool.
implementations, which might actually address exactly these cases.
Yeah.
We are also going to be covering that one in the new year with a YouTube video, because I really think people need to know a little bit more about it, and it might help people solve exactly these kind of problems in a nice and functional way, just like you said.
Yeah. So I guess that's about it for part 1. I mean, I've talked a lot about how I structure things and how I think like the functional way, but we should look into the reading head again and take the reading head, right?
I think so. But I do have to say, I think it's kind of really cool contrasting the first solution that you had with that, which may be less code at parts, but as you said, might bring you into debugging hell if you suddenly forget that maybe you made a change or something like this. And as we have heard from Roman a few days ago, the secret to being fast in competitive programming is to write correct code the first time, which is that's a mantra I now live by. I'm not sure how I'm gonna write correct code all the time at the first time, but I sure am gonna try. Yeah. So, but it seems that this change in coding or in style approach definitely helps going in that general direction.
Yeah.
Okay. We'll go to part 2. The reading hat is back on. You're worried you might not ever get your items back. So worried, in fact, that your relief that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. Unfortunately, that relief was all that was keeping your worry levels from reaching ridiculous levels. You'll need to find another way to keep your worry levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. With these new rules, you can still figure out the monkey business after 10,000 rounds, using the same example above. After round 1, monkey 0 inspected items 2 times, 1 inspected them 4 times, 2 inspected them 3 times, 3 inspected them 6 times. And then that continues until we get a cumulative monkey business after 10,000 rounds, where monkey 0 inspected items 52,166 times. Monkey 1 and 2 did a little bit less, and then monkey 3 inspected items 52,013 times. So, after 10,000 rounds, the 2 most active monkeys inspected items 52,166 times and 52,013 times. Multiplying these together, the level of monkey business in this situation is now, and we gotta do, this is 3, this is 3, this is 3. So 2,713,310,158. Worry levels are no longer divided by 3 after each item is inspected, so you'll need to find another way to keep your worry levels manageable. Starting again from the initial state in your puzzle input, what is the level of monkey business after 10,000 rounds? Well, that sounds easy, right? At first glance.
Yeah.
What were you? Where did your mind go for that one? Was it just change the timer or change the repeat to 10,000 and see if you can call it a day?
I must say, I've seen this many times happening. So my initial thought was, okay, this is going to be a puzzle again, where I have to figure out in what way the items wander between the monkeys. I was immediately sure that this is a trap that you could fall into, but I must admit, as I'm only doing this once a year, I'm not that much into like the arithmetic world immediately. So what I did is like, first of all, I was like, shit, I took int. this is the first thought that you really have when you started with int values, and you know it's not going to be enough. Yeah. And of course, if Eric Wastel says ridiculous amounts, you immediately know that even a long might be not covering this problem. But then the next thing is like, oh, maybe a big integer might help. Maybe, please let it help. Yeah. Because last year we had some puzzles that were solvable straight away with raw power, even if you had to wait like 5 minutes on your machine. But we all know, and people who've done Advent of Code for longer than just this first year, basically all of the puzzles are solvable with very old hardware. So we know there is a mathematical way to approach this. But in case you plugged it in, which I also did just to see how slow my machine gets and how far I could go, I didn't even get the demo input through. It didn't work for the demo input, and that's the key point. Like, you shouldn't try it.
Yeah. Okay, then let's jump into your code and see how you approached it then.
Yeah, basically, this is the first time in the series this year where really it's not about the code at all. It's about the mathematics behind it. So there is no secret trick to make the code now cope with these high numbers. Absolutely nothing. But I got something in stock here for you to see what the problems are if you had solved the problem part 1 like I did. And the first thing that you got as a problem is up here. So I have chosen to take int as the representation for the worry level. And this is definitely not enough. So here's one approach that could have helped me in the beginning. If I had just used a type alias for my worry level, I would be much quicker in changing it to long. Because if you look at my part 1 solution, the int, it's all over the place. It's like the same problem as with a stringified system. If every data type you have is a string, then you got a problem. If every data type you have is an int, you are in trouble. And of course, Kotlin has great ways, like the value classes, for example, to cope with these things. Type alias is like the little sister that I love very much. Like I can reveal intent with a type alias, and I do know there is a zero overhead. It's just like an alias to a long in this case. So what you see here, what I did is, just to show it to you, of course, this morning I didn't do that. So this morning I actually went into my code and went into every int, made it a long. But even that is wrong, because if you think about it, the model here, not everything is a worry level. Not every integer has to be a long. I mean, you could approach every problem in AOC with only using longs. That might be really helpful for most of the problems. But I'm not like that. I'm not wasting space on the computer. So as Roman said, I'm always like, okay, I want to be a little bit efficient at least. Even though I know the functional style is not the most efficient one, I dislike using longs everywhere.
Yeah.
So here you see what the problem now is. If you make a type alias worry level to make it a quick change, there is still some things that break, because every time where you enter that worry level, you had used toInt or null. And that doesn't change with a type alias. So you see here the function toWorry level. If I had used that one, I must change this type and this function. And also something that I've tripped over many, many times. If you do arithmetic with longs, you always have to give the 0L to make this work. And if you have scattered this all over the place, again, think of my divisible by function. Here you see it again. If you have the pattern of remainder equals 0 all over the place, it would take you a long time to find all the compile errors. And yeah, that's the problem.
Yeah.
So what I did is I went to long by changing this using a type alias. You can see my data class now has a worry level to worry level. This is what the operation makes out of it. But that's about it, what the code has to change for. Now we have to talk about the mathematics behind this. And it took me way too long. I had to stand up, grab another coffee and think about the problem. And this is also, I know then I'm lost. I won't be on the leaderboard anymore. But I get this bad feeling inside, and I have to leave the laptop behind me and have a coffee and ease my mind of that. So I hope nobody is watching who didn't solve the puzzle yet, because this is a spoiler then, yeah, definitely. But I would like to explain that to you the way I thought about it. We have to go to the one comment here.
Yep.
I put it in there. So if you think about it, if you have a monkey,
just very briefly squeeze, I think this one over here,
yes,
and this one,
sure.
Then I can make the text just a little bit bigger for people
yes.
to read along. Wonderful.
I hope this helps. So I just take two monkeys here, and let's look at the first one. The only thing in our model that a monkey does is it takes my worry level and does some predicate with it. And in this case, it's always the modulo, the remainder operation. Yeah. So the problem here is now, if you think of a monkey who's testing division by 3, yeah, that monkey would treat the numbers 0, 3, 6, 9, 12 all alike. From the perspective of a monkey with that divisor, it doesn't make any difference whether the number is 3, 6, 9 or whatever multiple of 3. So if you look at the monkey from the outside, from our human brain, if I do a modulo arithmetic, so I take the remainder when I divide the world by 3, then all the numbers by 3, and hand in the remainder of my operation to the monkey wouldn't be able to tell the difference. In the monkey's brain, the number 3 is identical to 6. And this technically is exactly what modulo arithmetics is all about. It's like the equality of two values in a modulus mode. And the modulus of that monkey is 3. So this monkey cannot treat with anything else but 0, 1, and 2. But if you have another monkey sitting next to that monkey and the other monkey's divisor is 5, that monkey would treat 0, 5, 10, and 15 all alike. So the trick here, and I've done that here when it ran. So the reason why your laptop or your computer gets slow is basically if you try to use big integers to solve the problem, the numbers grow so fast, it's technically still possible, but you eat up all your memory. The numbers get so big that you eat up the memory you got in the machine, and that makes it slow. So the trick is keep the numbers small. And in this case, if you put the monkey with the divisor 3 and 5 into the same world and want to keep the numbers low, what you have to do is you have to modulo the world, every number you hand at these monkeys, by the least common multiple of these dividers. That's the mathematics. Technically, it would be enough in this case to just multiply them. So in this case, 3 times 5. So 15 is the key to these two monkeys. If every number thrown at these two monkeys is divided by 15 and you hand in the remainder, then the world for these monkeys would still be the same world they live in. And now we already have the trick here. So we need to find a common modulus for all the monkeys in business. So you see here in this line 46, what I do is I have the monkeys and take their test divisors. And again, you might have guessed it, the LCM is a function in my library. It's the least common multiple of these numbers, and it basically uses the GCD to do that. It's all in my library. I can just throw the numbers in there and get the LCM out of that. Yeah, that's basically it.
And that's based on the GCD, the greatest common divisor.
Euclid's algorithm finding a GCD. Yeah.
Mm-hmm. Okay.
So basically, that's the whole trick. If you do this operation, so remember in part 1, Eric told us to divide the worry level by 3. That was the trick to keep part 1 in scope of small numbers. And basically part 2 said, now I release you to the real world and you find the way to keep the numbers low. And the key was to use that divider. Yeah. To do the modular division before you hand in the worry levels. And you see here in line 49, that's the point where we had the divided by 3 at the end of line 49. So all you do now is, instead of dividing by 3, do the remainder operation of common modulus. And then everything works and there is no problem. 10,000 operations for these monkeys is nothing. Even without any more optimization, it's instantly done. It's like less than 100 milliseconds on my machine. I don't know. I wouldn't even care to do any more cleanup or efficiency here. Yeah.
Yeah, makes sense. Yeah, so this one it really does. It's kind of fun how it boils down to what is essentially a 2-line change. But it's just all about if you can come up with this concept of a common modulus world, I guess, or the least common multiple. Then that's kind of what gets you there. In
our puzzle, all the monkeys I had, I think everybody had these monkey types. They all use prime numbers. So technically, you don't even need to understand the least common multiple. You just multiply all of the numbers, and that's it. It's the product in this case. It would be enough to use the product.
Yeah,
the rest of the code didn't change. That's the only change you had to do.
Look at that. It's just I'm not sure which one I like more. The one where I just have to frantically race to write a bunch more code to change the way the simulation works, or the one where I have to stare very intently at like the 3 lines of code responsible for whatever's happening.
Yeah. So the worst thing that could happen in AOC is that if you don't know that solution, and I didn't know for like half an hour at least, then your brain goes like, wow, what's going on here? How could I ever? I even tried to sketch out how the monkeys relate to each other, which is completely nonsense. So if I did more of those puzzles, I think this is a very easy thing for all of those competitive programmers. Very easy thing.
Yeah. Most likely. Yeah. Okay, nice. Does that conclude part 2 for us then?
I think so. If you're interested in one little tiny nudge there, I thought this would be really fun because you love your new features of Kotlin so much. If you think about it, here it's take my storyline where I explain if you just change the world for the monkey. Yeah, so from the outside. That instantly reminded me of a cool feature that's coming to Kotlin, and that's context receivers. So why does that is a perfect match to this problem? Of course, it's technically not necessary here, but it's a perfect match to the storyline. So if I hop over to my final solution, you see a tiny change, and that basically explains everything. You see here in line 25 or 24, what I introduce here is a planet context. So all of these monkeys live on a planet, obviously. So it's Planet of the Apes. So the context is the planet they live in. And if you see here, what I do is operation worry level is what the monkey's business is. That's the same operation as before. But I call a function here, treat on this planet. And this function is basically brought to this function play with item of worry level by the context here. So this context is a simple, just an interface. And so the planet context provides you with one function, and that treats the level on this planet. And you can already see my two implementations for part 1 and part 2. Part 1, the scene for part 1 is the division planet. Every number is divided by a divisor. That's the context of that part 1. And the context of part 2 is the modulus planet, where every number is divided and the modulus, the remainder, is taken. So with this little tiny change, part 1 and part 2, if we scroll them up to the same lines, so you can put them both here, you see in part 1 I say, on the division planet with a divisor 3, do the code. And in part 2, look at these two lines here, these 4 lines, it's the same thing. So only on modulus planet we do that. And the only 2 lines before.
So these two is what you're saying are essentially identical.
Completely identical to this.
Yeah.
I love that feature.
So it's really, well, yeah, it's, you can, I guess some people like to think of it as like this dependency injection style thing where it's like, well, you define something and then it just absorbs the context that surrounds it. And that can change the behavior like you did here, even though the functions are or your function body is essentially the same. Yeah,
I like that very much.
Nice. That is actually a really cool way of introducing another Kotlin feature into this little problem. So you at least got to write a little bit more Kotlin, even though it was just a one-line change. And
technically, it wouldn't be possible without context receivers because of one little tiny thing here. You see, in this function, we already have an explicit receiver, the monkey. So without context receivers feature of the upcoming Kotlin versions, you wouldn't be able to do that.
So you couldn't just hack it up with an extension function that was just named differently, or that was working on a different receiver. No, you actually, since you have 2 receivers in scope here, you need to have the context.
And it also makes much more sense this way, because otherwise I would have to put the play with my item of worry level inside the planet context, and that would break the storyline. The planet doesn't play with the item; it's the monkey.
Yeah, which is quite, again, it signals intent, as you mentioned, which is really cool. Nice. Those were really, really sweet solutions. We can take a very brief look at what I made, but I think in comparison, is you're not gonna be. Essentially, we've discussed this problem to death. So we'll just very briefly talk about this. As usual, I also take the input by groups. This one is now burnt into my brain, and I'll never forget that one again. I just have my little extension function, which creates me a monkey class, which, as you can tell, looks very similar to the one that Olaf built in the first one. Carries a mutable list, carries an operation, which goes from longs to longs. I didn't actually choose longs in the very beginning. Those were modifications I made in the middle, in the unfruitful hope that maybe it's gonna be enough, but of course it wasn't. Pretty much all of this code looks the same, even to the point where, we drop the first line, because then we can properly destructure it without having to add any extension functions. I do the parsing just a little bit different, just checking for digits instead of casting to an int directly, or trying to cast to an int directly. As you've mentioned, this thing returns a nullable value. If you can parse it as a number, that means in this case it's always old as a value. So it's the same story here. The other parsing I don't think is very interesting. At this point, since I knew that we had only single-digit numbers for the true and false monkeys, I just went straight with the digit to int function, which, as was it Ilya, I think, has told us was the changed version of the toInt function for characters, because otherwise you're getting kind of confused about, do you want a code point as an integer instead of a char, or do you actually want a digit? So unambiguous here. Creates the monkeys as you would expect them. My sleepy brain today in the morning wrote the silly version as you said in the beginning, which was just using a for loop, and for each one I increment my mutable inspections counter. And this, of course, the moment you start doing things like removing items from the list that you're iterating over, because you're done with that item, you get a concurrent modification exception. Because I wasn't sure if they were always gonna throw all the items, instead I opted for just keeping a list of like removal indices, and then just kind of removing those step by step afterwards. It's not a very nice solution. I would not recommend anyone write this code, but that's just kind of what I spat out rather briefly.
I like your true target, false targets better than my if true, if false.
Thank you. Yeah, naming is a hard problem. Yeah. The other thing actually is also that I just pass in the list of monkeys as a parameter, which allows me to just say, okay, well, while inspecting this, you operate. I guess this should also be in the context of a monkey group, which you get to do modifications on. But yeah, apart from that, all of this is pretty much the same. As you can see here, I tried to do some very casual benchmarking of seeing if I could even get through the first 100 iterations with things when I was experimenting with stuff like big integers. Didn't get very far, very unsurprisingly. The output that I got for this whole thing is, again, a line that we've already seen today. It's just kind of getting these two. I wanted to make sure that we're not accidentally overreaching the integer range, so I just cast them too long before I do the final multiplication. And as you said, the trick behind getting I called them divisibilities in my debilitating state in the morning. Yeah, it's like the common shared modulo is just the multiplication of them. And if you don't have a cool library like Olaf does, you need to write something like a reduce function, which just does the arc times lm. Or I guess you could even do a long times. I think you could do this, right?
Yeah.
That also works. It's just a little shorter.
Sometimes this trick helps to avoid the nested its. I dislike it when I get the warning, because I know that the warning tells me something, shadowing. Mm-hmm. So I sometimes go for these function references also,
Yeah. And then just so that this adds at least some value to maybe someone, after looking this up and kind of checking this out a little bit, there's also a name specifically for one of the theorems that you can use to kind of get this solution, which is the Chinese remainder theorem, which is that if one knows the remainders of the division, then you can determine the remainder of a division by the product of the integers if they are pairwise coprime, which luckily, since all the numbers, now that part, while I was solving it, I didn't even check that. I just kind of I did that on a whim, and I was like, let's see if this works. And it did, which was, I guess, lucky. But yeah, since they're prime, you can just multiply them up and you get to the same thing. Apparently, and I actually personally don't remember that directly, this Chinese remainder theorem has come up in previous Advent of codes before, pretty much verbatim, or at least in a very, very similar form. Yeah, but that's kind of just my take on all of this. Jonathan says, flashback to math classes in university identifies. Yeah, it absolutely is. But, at the end of the day, the whole computing thing is really, yeah, it's both what we do on the machine and in theory, right? Yeah. Nice. Okay, well, that's another mystery solved. I'm excited that we're one step closer towards saving Christmas. And I think we've gotten ourselves to the point where we deserve a little treat. So why don't we talk just briefly also about your visualization stories, because they have made our streams over the last couple of days so much more colorful. So I want to say thank you specifically myself and also from the community for you providing these and writing them in Kotlin.
Yes, you're welcome. Well, it's a very short story. So one time a few years ago, I've just watching through YouTube, finding a guy who's doing C++ videos. It's OLC, One Lone Coder. That's his nickname. And this guy has a library called Pixel Game Engine, which I can highly recommend. It's already translated to many languages, but not for Kotlin. And when I was on the lookout for, especially for AOC, I have no other business than AOC for doing visualization. So I'm not a pro in that respect in any way. So I have colleagues who do 3D visualizations that are like also very, very cool. But I wanted a tool for myself to do a quick and dirty approach of visualizing the AOC puzzles. So when I saw this video of the Pixel Game Engine, I went over to the source code, and it's a C++ header only library. And in my code, if you check out my GitHub repo, you will see that I did a port to Kotlin for that. It's in the utils, and it's called Pixel Game Engine.
If you want to click in there, I'll just follow you. Yeah, exactly.
Yes. So no need to go deeper inside there. So basically what I did is I spent a little bit of time investigating into the AWT and swing stuff of Java. So how can I quickly get a window? That was long before we had any Jetpack Compose or something. I've never looked into that, actually, only for Android development, but I'm not sure. Maybe there's cool stuff coming. So what I did is here, I create an AWT window with a JPanel inside, and all of the rest of that library is basically a port from C++ to Kotlin. Actually, a fun thing if you basically copy and paste C++ code and then you start removing semicolons and do some nifty things that you need to do for Kotlin, like coerce functions and stuff like that. That's very much fun, yeah. So, but the cool thing is that in the end, once you have that library in place, a visualization, if you follow me here, is quickly done.
So this is the visualization I think that we saw yesterday,
yes,
correct?
Yesterday, yeah. So basically, all you have to do is you extend that Pixel Game Engine, and you provide two functions, on create and on update. These are just two functions you write. And basically what this thing does is it calls on create in the beginning, and you construct the window you want to look at. So you're telling it how many pixels you need, and it's all in the retro fashion of blocky graphics. So don't try to have thousands of pixels. It's like 40, here in this case it's 50 pixels times 16 pixels. And this pixel width basically defines how large on the real screen, how many real pixels does one virtual pixel use. That's how you get the blocky character. And because it's so easy inside the onUpdate function, what this little thing does is it calls the onUpdate in a loop, in an endless loop. And in this function, you are free to do whatever you want on a canvas. So this is me hacking dirty, putting frame limits. So this is just dirty code, but it's very, very quick and dirty. And the cool thing is down here, you might see that draw CRT is a function that I put in here, and here inside draw CRT, this is how you get pixels on screen. You basically just say draw on a certain position with a random color. That's a function I wrote, and that's it. So the library has draw pixel, draw line, draw rectangle. It has some color functions I added to it. You can mix and match colors. It's all very, very basic. But it's quick enough, and I was happy because the intent of that C++ library is obviously to be very performant. So this guy does everything low level. What I do here is like basically working on an array of colors, which is my virtual screen, and then my JPanel function does a repaint, and for every pixel block, if you say your pixel size is 10, what I internally do is I draw a filled rectangle of 10 by 10. Yeah, so I was amazed that it's fast enough to do that, but I'm very happy. I use that every year to do whatever feels right to visualize in AOC.
So this is a library that that you're planning on open sourcing, or that's open source, or?
Yeah, you can. I put the license of this OLC. So the only thing OLC wants is he wants to know people to learn about it. So I'm telling you, go to OLC's site and look at this nice little library. And in my library here, in the AOC library, you will find this function. So yeah, there it is. What I think is a cool trick, because Seb, you asked me, is there some kind of a library to include? So the only thing is, it's like the Kotlin way of a header-only library. You basically copy one KT file into your project, and that's all you need. As long as you're on JVM, of course, because you need JPanel and AWT and stuff like that. Yeah. Mm-hmm. But other than that, you can copy that. And please keep the license MD in there, because OLC should get the credit for that. So the draw functions are basically just a one-to-one port from C++ to Kotlin. Yeah. And there are other Rust ports and other things already there. Yeah. But I felt I needed a Kotlin way to do that.
That's very cool. So I guess the call to action today for people would be to maybe try their own hand at maybe some visualizations for the future days if they lend themselves to it. Because not only does it look nice, I guess you can on the one hand, you can be a little bit creative, and on the other hand, it probably provides you afterwards with an even better intuitive understanding of what Advent of Code just made you do.
Yeah. So one of the easiest puzzles this year to visualize here is the tree thing. I did the tree thing also. And basically, if you have the heights of the trees, that was day 8. If you have the height of the trees, to visualize that, it's this 3 lines. It's like for every pixel in the dimensions of that map, draw the pixel, and here is just a lookup, and you see the coeers. So what I did is I created a color swap from dark red to bright red, and then I just mapped 0 height trees to the darkest color and 9 to the highest color, and that's basically it.
Nice.
Very easy stuff for many puzzles. And it helps a lot to understand the puzzle even better. Yeah.
So people, I guess, can find your implementation of all of this in your repository, which I've also put up on screen here. And I'm going to make sure this one is also linked in the chat there if you want to check it out. Because it's a really cool way of kind of doing a little bit of extra homework. How would you say, like, how much time does solving the problem versus visualizing the problem usually take for you?
I would say it's a almost 1-to-1 or a little bit to the side of the visualization way. So 1-to-1 is the quick ones, and 1-to-2, so double the time for the solving to visualize it properly would be for more complicated things. So the most complicated things are when I really want to do an animation that has different scenes where something changes. So one year we had a puzzle where a maze had to be explored. I love these maze things, so I hope they come up soon. So when there is a maze inside of AOC, I immediately want to visualize it, and then you see how the maze is traversed with whatever search algorithm you plug into it, and you can even visualize different search algorithms. So depth first, breadth first, whatever. It's a very, very cool way to learn about these algorithms and see what they do. Yeah.
Nice. Wonderful.
And you might have already...
Yesterday I've already briefly mentioned a book called Mazes for Programmers, which I'm a big fan of.
I will definitely read into that. Thanks for the advice.
Can recommend. Also, if you do get the paperback version, it is in color, which is great because there's a lot of, as you said yourself, you have like gradients, you have the visualization of how an algorithm might explore a maze, all these kind of things. So definitely worth checking out. Wow, cool. Well, that was really exciting, Olaf. Everything from seeing the solution to seeing a little bit behind the scenes on how visualizations are done. It's really nice. So thank you so much for coming on today.
Thanks for having me.
Yeah, it was an absolute pleasure. Now, of course, we hope that we're going to see you again tomorrow, because we have another very special guest. We have Dave Leeds coming on. Same time as today. And that is going to be the grand finale before I I'll leave for my winter vacation. So I'm very much hoping to see at least as many of you over there as we did today. Thanks so much for tuning in. Make sure you enter one of the leaderboards if you haven't yet, and check out Olaf's repository. Apart from that, have a wonderful evening, night, day, wherever you might be, and we'll see each other tomorrow. Take care, everyone. Bye-bye.